Hello and welcome to Mix and Jam, a channel about game development experimentation, and today's project is inspired by the Mario Party franchise. I've always been a big fan of this series and have covered the recreation of some of its minigames in previous videos. But this time around, I wanted to dissect the core gameplay of the playable board, in which players move around, collect coins, items, and stars. So in this video, I'm going to go over the process of how I tried developing a similar system using the Unity engine. The most important aspect of this project was to determine the tools that were going to be used for designing the boards. You see, in a real game production, it is crucial to have systems to facilitate content creation. And because boards are a key element to Mario Party, creating them should be easy and intuitive. So after some research, I've decided to use the Unity Splines package as the backbone for this project. Not only is this tool intuitive for building paths, but it also provides a robust API that would allow me to build logic on top of it. A spline on this context is made out of several knots, and these knots are points in space that determine its path and shape. My plan was to use the actual knots as the board spaces in which the players would navigate step by step. The Splines package already includes a script for animating an object along the path. However, the default movement on this component is based only on time or speed, which wasn't exactly suitable for this case, because in Mario Party, characters move by a specific number of steps. So to replicate this behavior, I created a version of the script that moves the character based on the spline knots. Here's how it works. The code calculates the player's current position on the spline by taking the index of the current knot and finding the next knot in the chain. It then uses the convert index unit function to determine the time values of these 2 points and interpolates between them to create smooth movement along the spline. The movement is then repeated for the number of steps specified by the function. Next, I focused on properly handling junctions. In Mario Party, when players reach a junction, they can choose which path to follow. In Unity though, these alternative paths are actually represented as separate splines. However, we can identify connected knots because they're considered linked knots. So as the player moves along the spline and reaches a linked knot with diverging paths, the code detects this as a junction. So at that point, the movement pauses and the game waits for the player to select a path before continuing along the chosen spline. At this point, the knots needed a visual representation to replicate the board spaces in Mario Party. The Splines package also includes a script for instantiating objects along the spline, but it has the same issue as before. It does not have an option that works per knot. So for this, I created 2 scripts. One that would be responsible for the instantiation of prefabs exactly on the knot positions, and one for the prefab themselves, storing any data needed for the future. Along with all this, I made a very simple model of the board space using Blender. To already start with some visual improvements, I added the official 3D character from the channel Jamo into the project. I created a visual handler for it that listens for all the game events and triggered the appropriate animations, all of which were downloaded from Mixamo, including locomotion, reactions, jumps, and so on. Next, I started working on the rolling dice animation. The object itself is just a cube with text labels on all sides, and it is also a child game object of the character, which would allow the code to enable or disable it whenever needed. Animation-wise, the cube simply spins around while quickly shuffling all numbers. Then I made a quick sequence in which the player activates the jump animation, hitting the die object and making it immediately stop spinning and display the sorted number. To replicate the original game, I added a several set of cameras that would be triggered based on specific game events. So for example, when rolling the die, it activates a camera that zooms in the character. And it also uses the volume settings to adjust the depth of field effect, allowing it to focus on the player while blurring the rest, just like in recent Mario Party entries. I also added a more top-down camera for when the player reaches a junction, giving more visibility on the path selection. And speaking of which, I added visuals for the moment of this selection with a little 3D model of an arrow for each direction, while also adding some feedback by modifying their color and size based on the selected path. Then I focused a bit on the UI and visual elements. I began by implementing the roll number display, ensuring it dynamically follows the character as they move. I also added a set of simple buttons to showcase all possible player actions. And to mimic the style of recent Mario Party games, I integrated an overlay camera that displays a larger render of the character on the left side of the screen. Another very important part about the game is that the space where you land determines how many coins you're going to gain and which events are going to be triggered. So to replicate this, I went back to that data script located on the space prefabs and added a variable that changes the player's coins. To visually represent the coin modification, I created two particle systems that display the gain and loss events. When coins are gained, the particles emit from the top of the character, and for losses, an explosive emission originates from the character's position. Next, I decided to focus on the star purchase event. While the logic for this was pretty simple, which just adds a number to the player's total stars, I still wanted to capture the flair of the original games. And here's how I approached it. When a player enters a star space, the game triggers a special event that pauses movement and waits for the player to decide whether they're going to buy a star or not. If they confirm the action and have enough resources, a timeline sequence activates. During this sequence, the camera rotates around the player, and then we can blend animations building up the excitement of acquiring a star. At this point, the project was nearing completion. But before jumping into the final polish process, I decided to create a simple level structure that takes advantage of the Spline system. During my research, I found an open repository by Roomsick that provided a tool to modify Unity's terrain using splines. This was perfect for my needs. All I had to do was to adapt the tool to use Unity's spline system instead of its original path implementation. With this, I could modify the terrain's height and paint textures to match the board layout. Although I kept the modifications very simple for the purposes of this video, it demonstrates how easy it is to scale the project with the solid structure and foundation that the splines provide. And finally, to enhance the overall look and feel of the project, I made several visual improvements, starting by the dice roll, in which I added particles and a light emission for the moment the die is hit, along with confetti particles when the roll number is revealed. I designed a proper coin model and improved the feedback for their particle emissions. And then I created a custom star model, added a spinning trail effect, and incorporated additional particles for that purchase moment. And after a bit of adjustments, this is how the project turned out. If you're interested in downloading the project and checking out the code behind it, there's a link for the project's repository in the description of this video. A huge thanks for those of you who support me on Patreon, including these top tier supporters. If you want to see more videos like this, consider subscribing and sharing this video with friends. Thank you so much for watching, and I'll see you in the next one.